Hello everyone, this is Mr. Jackson, and we're going to get into part 2 of our Module 4 lecture over the blood vessels, specifically focusing in on physiology of circulation. So, we're going to start with our vital signs. So whenever it comes to our blood vessels, there are several vital signs that would apply. Typically, whenever we refer to vital signs, we are talking about arterial pulse, which is clearly applicable here. Blood pressure, which we're going to talk a lot about, but also respiratory rate and body temperature. Those are what we refer to as our standard body vital signs. So arterial pulse is one of those that we're going to go ahead and cover what that means. This is just referring to that alternate expansion and then the recoil of a blood vessel wall, sort of like that pressure wave that occurs each time the heart beats. And we can actually monitor that pulse rate at the various pressure points. You can see those pressure points. I'm actually covering one of them, so let me drag myself up here for now. But you can see these various pressure points on the diagram that I provided. These tend to be the most superficial arteries where you can easily palpate the pulse. And also, the closer that you happen to be in those pressure points, the closer that you are to the heart, the higher that pressure is going to be, and so the easier it's going to be to take a pulse. So that's something to keep in mind. You can see these various arteries and their names and their relative locations. If you were to take two fingers, so your index and middle finger, not your thumb because it has its own pulse, but your index and middle finger, and you were to apply firm pressure over any one of those pressure points, you'd be able to find and determine your pulse rate. Pulse is going to average somewhere around 70 to 76 beats per minute whenever a person is at rest. Whenever someone is very well conditioned physically, like, they participate in a lot of vigorous exercise, that actually will go down for the most part. So your resting heart rate will be lower because you can more efficiently supply your body with everything it needs at rest. Myself back down here. So, blood pressure. Whenever we're talking about blood pressure, this is just the pressure that blood is exerting against those inner walls of the blood vessels every time that the heart beats. The force that causes blood to basically continue flowing. So we always are going to have a blood pressure gradient. So every time the ventricles contract, blood is going to be forced into those elastic arteries that are closer to the heart. And then it's just basically going to continue to flow along a pressure gradient, always from an area of high to low pressure. So this is a passive process. So the highest pressure being in the ventricles whenever those contract, and then it's going to continue going in a wave from that area of highest pressure to the systemic circulation or the pulmonary circulation where it's going from high to low. So pressure is going to decrease in blood vessels as they get more distant from the heart. Pressure is going to be highest in the arteries, lower in the capillaries and capillary beds, and lowest in the veins. You might remember from part 1 where we said that we have to have some extra mechanisms such as valves and the skeletal muscular pump to make sure that we can still go against gravity even because veins typically will exist under lowest pressure. And this is a really cool image where you can kind of see the relative blood pressure and where it's located, right? So you can see up here, there's a nice range of what that blood pressure can be between systolic, whenever the heart is contracting, and diastolic, whenever the heart is relaxing, and, or really the ventricles, to be, the left ventricle to be specific. So you can see here that at the aorta, right, just as the blood is being pushed out of that left ventricle, you can see that the blood pressure is relatively high. But as you get further and further away into those arteries, arterioles, capillaries, so on and so forth, until you get back to the heart as deoxygenated blood, you can see that pressure is almost non-existent by the end. So, measuring blood pressure, we've got two blood pressures that we typically measure, that we would basically say this is your blood pressure, and that's going to be composed of your systolic and diastolic blood pressure. Systolic is basically pressure in the arteries at peak ventricular contraction, right? So this is the highest pressure that your heart is going to be exerting on those arteries when it's active. Diastolic is the pressure that we read whenever the ventricles are relaxing, okay? So this is typically going to be expressed as systolic over diastolic, and we give it in millimeters of mercury. And that has to do with the measuring tools that we utilize. And an example would be, oh, my blood pressure is 120 systolic over 80 diastolic millimeters of mercury. We're going to take blood pressure primarily via the auscultatory method. This is just an indirect method of using arterial blood pressure, most often at the brachial artery, and that's going to be using a blood pressure cuff and stethoscope. And so you can see here the process. I won't read all of these steps, but most people are pretty well familiar. We've at least seen this process before, but I can drag myself up here so I'm not blocking any words. If you'd like to take a second and pause to actually read the steps involved of actually taking someone's blood pressure using that brachial artery, then please feel free to go ahead and pause now for a moment and review the parts of those processes if you choose. Okay, and so we're talking all about blood pressure. This is a key metric for getting a measure of the pressure exerted on, your arterial walls. And so there are a lot of different factors that will have effects on that blood pressure being, is it going to elevate it or decrease it? So our arterial blood pressure, BP for short, is directly related to your cardiac output, and that's just the amount of blood pumped out of the left ventricle every minute, right? So might remember that from Module 3. And that's going to be multiplied by the overall amount of peripheral resistance. So this is a new term, but that is referring to the amount of friction that blood would encounter as it flows through vessels. Remember, your innermost tunic, that tunica intima, is all about trying to reduce this peripheral resistance, this friction that blood would encounter. And so the arterial blood pressure is just a product of the cardiac output, so how much blood is being pumped, and the amount of resistance that it's experiencing as it's pumped through the vascular system. We have some neural factors, such as the autonomic nervous system. We're not really talking about the parasympathetic nervous system here, little to no effect on blood pressure, but the sympathetic nervous system does affect your overall blood pressure because it happens to promote vasoconstriction. This is where the blood vessels will actually become narrow, and because the same amount of volume is existing in a narrower blood vessel, this is going to increase blood pressure overall. So we do have some neural factors involved. There are some renal factors, renal referring to the kidneys. So kidneys can actually help us regulate blood pressure by altering overall blood volume in terms of how much water is circulating through the bloodstream. If your blood pressure is reading too high, then the kidneys can release water in the urine and decrease the overall amount of fluid in the circulating bloodstream to decrease pressure. And if it's too low, then it can release renin, triggers angiotensin II, which is a vasoconstrictor, and that'll help elevate by constricting your vessels. Also stimulates release of aldosterone, which enhances sodium and therefore water reabsorption, so we can actually bring in more water into the bloodstream if we need to increase that pressure as well. Temperature is going to have effect. Typically, heat has a vasodilating effect, meaning that heat will typically make our blood vessels become wider. And that makes sense. Anytime you see your body's surface becoming more red on a hot summer day, it's not because you're sunburnt necessarily, it's because your blood vessels are dilating. And then temperature will also, cold has a vasoconstricting effect. And that, you can think of, if you think back to part 1 where we said that we have those sphincters that would actually block off blood supply going to certain tissues. It's a perfect example for how cold temperatures are going to cause that, those sphincters to become closed, where it would actually redirect blood supply to more vital portions, or at least just pushing them through those shunts at the side of each tissue in the capillary beds. We also have several chemicals that have an effect. Various substances can cause increases or decreases. A lot of modern medicines can help do those things. But epinephrine is one of particular importance that helps increase heart rate and blood pressure. And I gave you a really useful image that basically just summarizes this, gives you some lines that basically say whether or not they increase a stimulus and what that end result might be. So this is specifically looking at increasing blood pressure by either increasing the cardiac output or the peripheral resistance, or both. Some variations that can occur in blood pressure. So normal human range, typically systolic, you can expect to be anywhere from 110 to 140. Anything over 140 is considered abnormally high. Anything below 110 considered abnormally low. Diastolic pressure is typically going to be 70 to 80. Now, if your blood pressure is reading low, this is often referring to your systolic. So we call this hypo or below normal tension. So hypotension is just any systolic measure that's below 100. Often associated with illness, acute hypotension is often a warning sign for circulatory shock. This is saying basically that your heart might not be pumping well enough or strongly enough. Hypertension is referring to the opposite, hyper meaning above or elevated, and that's tension. So high blood pressure, hypertension, this is referring to a sustained elevated arterial pressure. You can think of it as being like at rest, being over 140 systolic or over 90 diastolic. This is going to basically warn us of increased peripheral resistance. A lot of things like atherosclerosis, arteriosclerosis can often be the result of this increased peripheral resistance. And so this is something that we want to take very seriously if we're seeing at regular doctor visits that we're measuring high for blood pressure. And we're going to finish up here by referring to some specifics over capillary exchanges of gases and nutrients. So what we have to remember here is that this tissue fluid, interstitial fluid, is found between your cells. And substances are going to basically move to and from your blood and to and from your tissue cells through these very thin capillary walls. And this exchange is ultimately going to always be due to concentration gradients. So oxygen and nutrients are going to leave the blood and move into tissue cells that have lower gradients for those amounts of oxygen. So if there's lower oxygen in the tissues, you're going to expect it to leave the capillary and go into the tissue itself. And then carbon dioxide and other waste products exit tissue cells and enter the blood at these sites. Again, always because of these concentration gradients. And if you were to look here, you see a capillary as well. You see that single layer, and then you see the interstitial fluid. I provided this because it actually shows the four mechanisms. We don't have to go into them in any real detail today, but these are the four mechanisms through which we would expect to see those passive means of transport of these nutrients, again, going from areas of high to low concentration. And that is going to conclude our Module 4 lecture. That is Part 2. So in Part 1, again, we covered the microanatomy and gross anatomy of the blood vessels. And in Part 2, we covered everything physiology. And so I hope that you found this Module 4 lecture helpful, and we will see you at the next one.